Hey, AP Chem students, this is time for a real quick short one. Unfortunately, there's not a lot of places to read about this because it's kind of spread out throughout the book, but the positive is there is no homework for today, so that's positive. Remember particulate models or particulate diagrams, that's what we're doing today. So let's see if we can't kind of put that together. So we have these reactions that we actually wrote earlier in our earlier notes, and we're going to figure out, like, we did the water changing from a liquid to a gas. So here's the original equation, H2O liquid, and then we had our arrow, and then we became H2O gas. All right, so our key here is, first of all, we have liquid, so we have to represent water in a manner, and most of the time, what we've seen on tests and such is we've seen it represented by a bigger circle and then two littler circles attached. And we want it to be a liquid form, so it's kind of taking the shape of the container, just like that. Now, as a gas, here's the deal. We also now have to focus on our balanced chemical equation. So I have 3 water molecules on the left side. That means I have 3 water molecules on the right side. So I couldn't just draw like just one and be like, okay, I'm done here. Nope, that's not actually how it works. So we are going to make sure we draw 3 water molecules that are now gases. And this gives us a pretty good representation. All right. That's what we got there. So now going back to our sodium chloride, we had Na plus Cl2, right? That's a gas. This was a solid. And then we have 2 NaCls, right? If you want to refer back up, you can. Why I put 2 Cl2s on there? Let's just start this whole thing over again, huh? All right. So we have 2 Na solids, and then we had Cl2 gas, and then we had 2 NaCls, and those are solids. Okay, so if we look at our little graphic here, so we need something to represent Na, and we want it to be a solid, so I'm going to use triangles to represent Na. All right, it is 2 triangles. They are their own shape. They aren't taking the shape of the container. It is solid. Boom. All right. Then we have Cl2 gas, so we have to draw Cl2 gas somehow. So there's only one of those, so I just draw it much like that. And now we need NaCl, which is a solid, so we're going to have a triangle, circle, and that's our particulate diagram for that reaction. Okay? Awesome. So now let's move on to this next one a little bit here. Put my plus and my arrow in here. All right, so if we look at this one here, all right, we have 3 SrCl2s, all right, and remember they're ionic. It is ionic, so we have to represent that in some manner. So let's go ahead and for Sr, let's make those boxes. So we're going to have 3 boxes because this is an aqueous solution, so if you want to draw water across the top, you can. It's really not necessary, but again, and we're leaving the water out. So we're going to have 3 SRs. So our SRs are going to be represented by boxes. So we're going to have 3 of those SRs kind of just intermingled within this thing. All right, let's change colors here. Let's go for Cl2 or Cl. We're going to draw circles. So there are going to be 6 circles. All right, also within that solution. Okay, so let's do the same thing for Li. Pick a new color, and let's go triangle for Li. So there are going to be 6 triangles here. This one got a little more ordered, but we'll be okay. We're going to keep our... Yeah, let's go there. We're going to keep our PO4 all together, and that's going to be a yellow dot. And there are going to be 2 yellow dots there. All right, so now when we put this all together into like the same little tank, we're going to have 2 dots, right, for our PO4s. And then around it, we're going to have 3 red boxes. Okay, so I kind of boxed myself in here a little bit. Let's erase that dot there. Okay, so we'll go back to our boxes. There's a box, 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 and then Same thing, let's put our dot here, and then we'll put our boxes around it, kind of like we did last time. There we go. There's our solid, and then we have 6 circles, pink circles, so they're going to be floating here, spread out. Alright, and then we're going to do the same thing with our triangles. We're going to have 6 purple triangles. And this also maybe hopefully helps us identify our spectator ions. You can see that like these purple and pink things didn't change as they went through the process, so they're really not involved in the reaction. So it could technically be anything that's aqueous to get this to happen. Okay? Now if we look at this next one, all right, we're going to have a little different situation. All right, we still have our solutions here, right? Now, if we look at this, our H2CO3s, or our acetic acids, HC2H3O2s, don't break apart. In fact, very few of them break apart. So we're going to show that as all together still. So we'll have, let's have a triangle represent that, and we'll make a box represent acetate, but we're going to leave that still just floating in solution. I know my triangle should be red, sorry. Okay. There's that, just floating in solution. And then K, we'll have, let's have a circle, and then for our OH, let's do a green box in this case, all right? So we'll have one box floating, and it won't be attached to this circle, so they're separated. Then we'll have our waters kind of getting together, so we'll have a triangle, and they're going to stay together. A triangle with the green box. Is this the same color of green? I hope so. And then our K and acetate, so our orange circle, bloop, and our C2 or our acetate, purple, will be floating separately. And there we have it. Okay? Awesome. That's it. See you next time.